Suppose we want to know if 2 points are the same. So what do I mean by that? I mean that let's say we have a point, let's call it, let's write a new test method for this. Let's say test void test equal, and then let's say we create a point p1 equals new point, and we'll say it's at coordinates 3, 4, and then let's create point p2 with the same coordinates. So we want a way of saying that these 2 points are the same. Okay, so what this means is that we should probably write a method that determines whether 2 points are the same. Or rather, we can do something like p1 dot is equal to p2. So we could do this. We could write a method called is equal to that returns true or false to whether p1 and p2 are equal according to the criteria of having the same x and y coordinates. We could certainly do that. But the problem with doing it at least this way is that a lot of Java methods and classes and whatnot rely on equality comparison. Okay? And for example, even assert equals works this way. So let's first see what happens if we try to say, are P1 and P2 the same thing? So by default, Java will say, remember how when we drew our little heap memory model a long time ago? So if we create a point P1 equals new point, then inside of our heap memory model, that's going to create a space essentially for the point P1 with some information about it. And that information, of course, is the fact that it has the coordinates 3, 4, and of course there may be some other information as well, but that's good enough for now. And if we create another point, so like a new point with the same coordinates, that's going to point to an entirely different object in memory. Okay? And by default, Java will use that referential equality for comparing two objects. So these two objects are actually not the same. They don't reference the same thing in memory. Okay? And we could actually figure this out by doing P1 equals P2. Remember that this uses something called referential equality. Also sometimes probably called exact equality. And that just means whether the two things are literally the same thing, like whether they reference the same thing in memory. And of course these two absolutely do not. And what we want instead is a way to say, okay, well, we want to tell Java that these 2 points are the same. Okay? And in fact, there's a way to do that. There's a method called dot equals. Every single object in Java, every single class, has this functionality. Okay? So we can do p1 dot equals p2, and this will return whether the two things are the same. And in fact, we could even write something like assert equals, or assert true rather, and this is of course going to return false. And in fact, this is the same thing as this. So what it will do, when you call assert equals on two objects, it will actually just call the dot equals method on P1 and then call it with respect to P2. Okay? So how do we do that? How do we want to tell Java that we want to say that the 2 point objects are the same? Well, there's a way to do that. The way to do that is to override a very specific method from what's called the object class. So we want to tell Java that don't use this default way of comparing objects for equality. We want to instead tell Java that if we have 2 points, compare their coordinate values. So how do we do that? Well, we're going to type this method header, and we're going to type it exactly how it is. You have to type it exactly like this. Okay? So public boolean equals, and then as a parameter, you'll pass an object, and we'll just call it O. Of course, it doesn't matter what you call it. You could call it anything you want, but O or obj or object with a lowercase o, that's fine. But everything else, all four of these components must be here. The public, the boolean, the equals, and the object. The override doesn't necessarily have to be here, but you should always put @override if you're overriding a method. Okay? And we'll talk more about overriding methods later, but for now, just always put @override when you're writing .equals. Okay? So the first thing we need to do is first check to see if obj is even a point at all, because this is an object. So what we could do, in fact, is say like assert false p1 dot equals, and we can pass anything here. We could pass in a string here, and of course this should return false. And let's just finish this, because there's no way that p1, the point, can be equal to a string. Okay, so this had better be false. So how do we check to see if obj is a point? Well, let's first figure out what to do if it's not a point. So how do we do that? We say if, we're going to say if it's not the case that obj is an instance of a point, then we return false. What does this mean? This means that if there's no way that obj can be a point, then we return false, because there's no way that we can possibly interpret obj to be a point. Okay? So what if it is an instance of a point? Well, remember when we first talked about casting? Well, we can create another variable, and we're going to cast obj to be a point. Okay? We're going to cast obj to be a point. And the reason why we can do this is because if we couldn't do it, then this condition would not be true. So this cast is always safe because we have this condition here. Okay? Now, if we tried to just cast it like this, then we might run into something called a class cast exception. And in fact, that is what would happen if we tried to cast let's say a string into a point. So let's see what happens. So we get a class cast exception. Okay? That means we're trying to treat something that cannot possibly be that thing. In this case, we're trying to say, okay, treat a string as if it were a point. And there's no way we can do that. Okay? But what if we can? Well, we now want to say, this is the easy part actually. We want to return whether this dot x is equal to other point dot x, and whether this dot y is equal to other point dot y. Okay? So we're saying if this point x coordinate, remember this is the implicit parameter, so in here it would be p1. We're saying if this dot x is equal to the parameter's x coordinate, and the y coordinate is equal to the other point's y coordinate, then that must be true, and this will return true. Okay? So let's rerun this and see what we get. So this should be false, this should be true, and now assert equals will work as expected. Okay? So we can do something like assert not equals for new point 34, new point 33, and then we can check. So this is checking the difference in the y coordinate. Now let's check a difference in the x coordinate, and now we can check a difference in both of them. And so assert not equals is basically saying, is this false? So are they not equal according to dot equals? And as we expect, all tests pass. Okay? So the main thing here, there's three big steps. Well, we have four actually. We have one, which is copying the header exactly as it's written. You cannot omit anything here. Okay? We then say we have this check that says if we can treat obj as if it were a point, or if it were whatever class you're in, if we can't do that, return false, because there's no way they can be equal. Otherwise, convert it into that, and then check the fields.